Yeah. Yeah, she said something about present the results, and I'm like, how are we going to present the results of a proposal? I don't understand that. I guess I'll talk to her about that like a week or two before.
All right.
So I just was doing it so like,
but it's only that Spanish marker.
Continue this.
That's what.
So remember, we use AIC. We use AIC to find the best model. We had an interaction term. So now what we want to do is we have to keep school in our model because it's significant. And then we're going to do subsets to see if we can explain time to graduation and major. So we started with these restricted permutations. Back here, right? So we had the script. I had gone through and modified it just a little bit. So we had this dat line. So that way we can give it the data frame, we can give it a subset. And then some other things that we could do, like I could also do like, you know, make my own strata, so that way it automatically factored everything in. But I think it's easy enough to where we're not changing a whole lot in the script. And then what it's doing is basically with the strata in the school, we kept school constant. So again, let's bring this over here. Zoom in on it. It's like really dark. That's better. Oh. Say this is school variable. That's our school variable. We've got salary, you know, y is over, say, off the board in this area where we see the different salaries. And then we're trying to shuffle, which one was this one? This was time to grad. Yeah, we are testing, time to grad. Time.grad. All right, so we've got less than 4, 4-5, 4-5, less than 4, 4-5, less than 4, and 4-5. So then what our restricted permutations is doing is it's not shuffling this entire column, it's shuffling those and it's shuffling those. So that way, all of these are still tied to the salaries from school B. All of these are still tied to the salaries of school A. So that way we've maintained that school salary relationship. All right. So we did that. We did our omnibus test, which was that ANOVA, restricted permutational ANOVA. Saw that time to grad was significant, and then this is the subset part of it. So our pairwise. So then I asked you to kind of work through and do all that other stuff because it does take time. Right? Take time to run. Did you do them all? They all work out? All right, so our p-values are going to change a little bit just because it was randomization. All right, so oops. Major. We did, that was major. Let me get to here. Here it is. All right, so for science makers, we had, these are the p-values that I got when I ran it. And this was for our comparison. So less than 4 versus the 4 to 5. For the less than 4 and 6 plus, I got that. For the 4 to 5 versus 6 plus, I get this. So then Those are our p-values. We have to adjust them to account for inflated type 1 errors. What we get is that they're all different, right? So time to graduation does vary based on our science majors. For the non-science majors, same thing. All right, same thing. Then that next step then is to say, all right, let's look at time to graduation to see if major has an effect. Again, dat.L4, I get a p-value of 0.1, p-value of 0.01, and then a really small p-value. So for those individuals that graduated in 4 years, in less than 4 years, less than 4 complete years, there was no difference between science and non-science major salaries. But there was a difference if it took 4 to 5 years or 6 or more years. And that's exactly what the graph is basically showing, is that when you looked at that less than 4 year graph, this one, there's no difference between the non-science and the science, but for these other years, the science majors ended up starting out with a higher salary. And then we took it that next step and said, okay, well, within the science, yeah, each of these points is different. We took it now a complete analysis from figuring out what our simplest, most parsimonious model is. And then once we have that model, taking it that next step to really investigate how the individual independent variables influence our dependent variable. All right, so just kind of as a summary here, school affected salary. It was a main effect in our simplest model. Once you have that, you can just go ahead and do either your Tukey's if we have 3 or more levels, or in this case, 2 levels, you just look at the averages. And we also saw the significant interaction between major and time of graduation. And as we just said, no difference between science and non-science majors if you graduated in less than 4 years. But there is a difference between your major if you took 4 or more years to graduate. And then, of course, starting salaries decreases, time of graduation increases. And just happens to decrease faster for the non-science majors. So we can say that, hey, be a science major if you want to make more. Probably not entirely true, but you know what? It's nice to pretend. So how do we present? What do we present? Right. As we said many times, you don't only have to present the figures that really show what you're trying to drive home, the point that you're trying to drive home. If you had the simplest model is none of our variables had an effect on salary, you really don't need a table. You really don't need a figure. It's very easy to say none of these had an effect. But if we do have an effect, many times it's best to just go ahead and show a figure. Some people see words on a paper and they just panic. So here I present 2 different figures. One's a box plot for public versus private school. Do we necessarily need one of those? No, we don't. Again, 2 levels. It's simple to say private salaries, starting salaries for private school is higher than starting salaries at public school, and that's like mean and standard error and so forth. All right, and then for the interaction, I went ahead and did the interaction plot. Now, here's our total write-up. All right, and there's going to be some things to really kind of emphasize. One, I reported global stat and p-value for our GVLMA. We use the GVLMA package to assess our assumptions. And we saw that, yeah, assumptions of ANOVA were violated. So for that, we had to use stepwise methods with AIC as a selection criterion. That is typically sufficient to explain what we did. All right? Some people could say, hey, we need a citation, in which case it's pretty easy to get a citation. How do we find a citation for that? No, we already know how to do that. How do you find your citation for GVLMA? It's in the package, right? All right. But now, let's say you wrote this. You said, Dr. Negavetich has this. This is what I did. Actually, this is maybe Cameron is at this stage. I haven't read her copy yet. But maybe someone says, hey, this part, stepwise methods with AIC as selection criterion. I need a citation for that. that shows me that that's acceptable. How do you start? How do you find it? You can't just say, well, Dr. Negavetich says that's fine. How do you solve it? Anyway. What's that? All right, let's do that. What would you search for? Not yet. We'll get to that because we'll also do the permute. What function did we use? Step. All right, so let's search our step package. Choosing a model by AIC in a stepwise algorithm. I'm going to scroll down through the help file. It explains what you're doing, right? It explains how it's all using. Then you've got these papers. You got an author of the package, Ripley, and then you've got the references. These are going to be pretty good references to start. Go to those books. Go find Modern Applied Statistics with S. I believe the library has this. Go look at it. Go look at what information criterion is there. In that book, they should say, this is an acceptable method to find a simplest model. If that's the case, if you find it in that book, yeah, use that as a reference. This serves as a reference for how we did it. All right? If you want to do generalized linear models, I'm sure Venables and Ripley probably utilized some of the information that was in Hasty and Prey. I'm sure. All right? So, yeah, if you need a citation, that's how we start going for it. So, we said that's what we were doing, and then we said models with a difference in AIC of at least 2 were considered different, so the simpler model was retained. This one's a little bit harder to find. Venables and Ripley may discuss it. There's also a book by Anderson on model selection, ecological model selection. And if you need that reference, come talk to me. I've got it. I've got it. Basically, all the papers talk about that. All right, so after stepwise model selection, 2 models were best. One was school major time to graduation and a major time to graduation interaction. Note I gave the AIC value. That's important. That's important for our results. The other has the same variables in a school major interaction. And again, I gave the AIC. We want to tell the reader what these simplest models look like, what their AICs were, so that the reader themselves can assess, well, is this difference really significant? All right. So I do say school major interaction may be important. However, we chose to select the model with the lowest AIC as a best fit model. Sufficient explanation, right? So for post hoc tests, restricted permutational ANOVAs were performed to investigate the effect of major and time to graduation after accounting for school. The permute package in R was used to randomize our variable of interest within each level of school. Summary of the analysis is in table 1. Here's our table 1. Now, I could go ahead and say this in the text. For a thesis, you're going to probably want to do something like this. Kind of gets everything condensed so that the readers can look at it and say, okay, I could see that. Now, data set, time to graduate, right? Time to graduate, of course, we can't. That's what we're taking our subset of. So less than 4 years, major is significant predictor. 4 to 5 years, major is significant predictor. 6+ years, major is a significant predictor. For the science and non-science, it's not. This is 0.1. That's not a significant predictor. It says everything. But I'm also going to repeat it in the text. Now, we use the permute package. Do we have to cite it? Yeah, we do. How do we cite the permute package? Yep. Go to the help file. There it is. All right, restricted permutations using the permute package. Brings up a great help file here. Kind of a description of what's going on, which if you're still a little confused, check this out, this vignette. All right, but it gives like exactly what it's doing. So you can go through and use what's the function citation? citation permute. You can reference that, which is perfectly fine right here. Right? Or you can go in and grab the citations that he actually used as a reason for writing his package. So again, we're just kind of using the tools that we have at hand to find our citations. All right, so where did we leave off? Right here. Summary of analysis is in table 1. All right, so controlling for time of graduation, major did not affect starting salary for individuals graduating less than 4 years, but major blah blah blah. So again, we talk about pairwise restricted permutations. We talked about home p-value adjustment because that's what we did for post-hoc test. There is one thing that we didn't report. What was it? What's not reported up here? Why would we need ANOVA? Did we run it? Everything was stepwise AIC, AIC selection. We use restricted permutational ANOVA. And we've got most everything. There is one thing that we didn't mention.
Adjusting the fee.
Salary? That's what we're talking about. We did. So we did adjust the p-value. I do have it here. Pairwise restricted permutational ANOVAs with home p-value adjustment. I did.
Do state, right?
What's that?
We include state. We have 3 states here for data.
Well, it's not significant.
Fair enough.
So yeah, so if state wasn't significant, we just left it off. That would be like in the methods. Or you could say, hey, yeah, state was not a significant predictor. And at some point you're going to say in the methods that these are the data that you collected, these are what we're going to investigate. Okay, so why didn't we do that? Yeah, we went right here and said, GVLMA told us that the assumptions were violated. Does it really matter which ones were violated? No. With a model this large, if GVLMA turns around and says assumptions are violated, we just keep it at that. We don't have to say it was normality. We don't have to say heteroscedasticity. Just leave it at that. So that was good. There's one other thing that we didn't report, that I didn't report. Kind of important. Do we need a degrees of freedom? So what are the things that we have to report? Okay, name of the test. Did we report those? All right, we did that. Test statistic. Do we have a test statistic? No, because we're doing randomization, right? And degrees of freedom. We did randomization test. What else? P-value. Did we report those? Yep. Conclusion. Did we report that? Yep. All right. So what's that last one that we missed? And it's only ever comes in when we do a randomization. Oh, number of iterations. Number of iterations. Yeah, don't forget that. So yeah, I left that off. All right. It's almost like a minor detail, but it's kind of an important detail because it tells us what the lowest p-value is that we can get. So, and it makes a difference. If you have, 1,000 rows, 1,000 data points, but you only did 100 shuffles, chance that you get batches that say it's different and not different is high. You can get incorrect conclusions. So that wraps up our college grad. It's a lot.
Why did you leave it off?
Accidentally.
No, you mean it was a learning moment.
It is
You
learning
pick
moment.
it up.
Learning moment. All right. Now I didn't go on to that next model. Maybe an advisor says, well, what happens if that is significant? Maybe you do need to look at that. Then you go ahead and look at it. But we kind of said here, it may be important, but we're gonna pick the one that has the lowest AIC, and that's generally accepted. It's generally accepted.
Where in there would you have put the permutations?
Post hoc test, restricted permutational ANOVAs, and then probably in parentheses 10,000 iterations were performed to investigate. Okay. And then, yeah, probably again here, pairwise restricted permutational ANOVAs 10,000 iterations. Probably right. All right. Now it's your turn. Clothing. T-shirts were purchased from numerous retailers. These are imaginary T-shirts, imaginary retailers. Everyone knows that if you're going to buy clothes, you just do it off of Amazon, right? Delivery. Easy. You got everything. Yes, that's why the camera's pointing this way for those watching it. All right, so yeah, again, as with most things, made up data set. All right, so for the T-shirts, what we did was we have nation of production. So look at the tag, like made in wherever. So 3 different nations. We've got 3 different shirt sizes: small, medium, large. We've got the age for the shirt, so either children's size or adult sizes. We've got shirts that are either men's shirts or women's shirts, or girls or boys' shirts. All right, and then we've got the dye. So either the shirts were white or they were some other color. All right. Now with the T-shirt, what you did was measure the actual width of that chest. So from armpit to armpit of that shirt. And the question is, the shirt widths differ based on these variables. So, I mean, just offhand, we kind of expect widths to differ between adult and children's shirt. All right? We'd expect them to differ between small, medium, and large shirts. And we'd expect that. But is that what we actually see? So, what you're going to do, you're going to check the assumptions, and then find the simplest model. And what you're saying is that, again, we've got larger number of variables. We've got 5 different variables, plus our dependent variable. We're not going to be able to go through and do simple, like do a QQ plot for every possible combination. We can't do that. Likewise, we're not going to be able to make ANOVA tables and kind of step down by hand. So go ahead, work on that. We're going to find the simplest model. Hopefully, the model is the same.
Dumb answer. Like, I'm fucking no, bro, that was my best answer. Please stop. Why would you think that? Always.
Hey, Matt, nothing was worse than Evo Eco.
Oh, bro, you know how many wrong answers you gave in there?
There's like the four in there.
Was that negative?
Yeah, in that undergrad student.
It was me, you, and,
Cody in undergrad.
Cameron.
No.
Cameron was
Oh,
on,
yeah, she was
on the video.
She was in Houston.
Yeah.
Wasn't
she still shooting on this? Oh, yeah, she's getting like hundreds of tests.
Yeah, for sure. 100%.
That was the hardest class.
Probably not even.
That class was tough.
But it was all theoretical.
That was one of my favorite classes.
It was cool, but it was all theoretical, like nothing was just fun.
Evolutionary ecology.
That's a real major.
My brain's
Like,
away.
writing and writing the whole time.
This is about where he lost me in the lecture too.
So I believe what happens is this is simple side.
I have two simple models, but starting with
Yeah.
yes. And
And
then one starts with no is the simplest and has the lowest AIC. But the one starts with four, obviously the opposite of what I said.
Yeah.
That's the point.
What's the point?
Yeah.
Which one?
I said you start from the goal, but when we did it in the lecture, we like did something and redid it again.
Yeah, I guess it did.
We removed the four-way interaction, but I'm heinously bad at reading this. Okay, look, so removing the four-way interaction with radius AIC, an update, gradual, responsible, almost full, and update and minus this, look at that. So you guys, this is the same thing we have to make for yeah, we got going. Yeah, but you need to rerun it minus this to get the same model. If you were to leave that graph, or is it the local minimum and global minimum? I'm going global. I'm prestige worldwide.
Okay.
I'll take you to the store. Yeah,
Let's do that.
I think we got that.
Almost.
Where did you? Oh,
Okay. Yeah.
Yeah, it's underneath. I made the box.
That was, if you remember, well, we had the full model and it didn't remove anymore because the full model had a slightly lower AIC. So what we did, and the difference was two.
I was like, I don't
So
know.
we did.
You're asking me and then telling me.
Forced it to remove
I don't know, man.
To see what would happen.
to see what would happen.
Yeah, because even if you like go down.
That's why we did that.
Okay, sure.
Why are you gonna? I don't know. But.
I'm gonna think they want to go.
Okay, you do you.
If it works, you scroll to the bottom right.
Minus,
Yeah, okay.
where is that? Wow, this is a lot.
Yeah.
Cool.
What do we do with that? Watch you, when I get the right answer, you're gonna be all like.
You get the right answer, you're gonna be like, you got the right answer, now I can figure it out, it's right about now. This is already the full. Oh.
Did you get the same as the null?
That's it, hold on, stand by, stand by.
Just got the same exact thing.
That's good, right?
This is what we did last.
See, this is when I got when I started with mod null though.
Yeah, not knowledge.
This is what I get when I do.
Why do we need to put in mod null?
We don't know.
Why did we, so remember, why did we use the mod almost full? Because when we started with mod full, it couldn't drop that it couldn't drop that highest interaction term because the AIC increased slightly. That increase was less than 2. All right? So we said, okay, well maybe this is the simplest model, but then when we started at mod.null, it took us to a different model. We didn't converge on the same place. And when we compared those AICs, the AIC of that new simplest model is actually lower than the full model. So we said, okay, well let's force it. Let's drop that 4-way interaction and then start again. Perhaps we had to get through that hump, that low, the local minimum is what I called it. We had to get through that local minimum first, and then it converges on the same 2 models. That's why we had to do that. And we're at the same place, right? So the 2 models are different. So how do we get through that hump? How do we get through that valley? Let's scroll back here. This, our local and our global minimum. We had one model that gave us this, one model that gave us this. We have to get through here. We have to get it, move to the point, get it up here again. So when the model has a choice, it's going to have 2 choices. I can either go this way or this way, and hopefully it takes that new path that gets us down and causes convergence to that simplest model.
What are we removing from this model this time?
You're going to have to pick whichever one gives the lowest AIC, because again, not the lowest AIC, which one gives us close to that lowest AIC is probably the one that has closest to whatever it says is the simplest model. And you're going to probably use the update function to get there.
Right. Okay, so are there?
So you are at AIC. What's your AIC right now?
For which one?
16,610 for the simplest model.
Okay.
But then there are 2 that are only 1 higher and 3 more that are only 2 higher. So does that mean I need to factor in 5 other models?
Yeah, we don't know.
Right, because if the difference is 2 or less.
Where do you see that?
Yeah, see, on the roads here.
It's right above, so it's right above call, so it's right above the simplest model. That last bit. Sex plus age plus nation.
Yeah, so you got 1610.
Yeah, 16,610, and then
Yeah,
less
11.
die, 16,611 plus sex and age.
Okay, so you're at 1610, right?
Yeah.
What's the AIC of the other model?
Oh, the first one?
What other model?
16.
Did you start and go backwards first?
I have to scroll up a while. Yeah, so that's from full.
All right, so at that point you're at 16,616, right? 16,616.
No. Well, but that's where it starts, yeah.
That where it starts?
Yeah.
Yeah, that's the end of the full model. You did mod full.
Maybe I didn't do the whole model then.
Hey, you should have.
If you got 16,610, that's when you start from null.
That's the no.
I didn't start.
Is that the null?
You did.
This one is mod.full.
You did.
Yeah.
This one. Mod.full with the skill.
Did you use that one?
I did.
Did you have a mod full as one and then a mod null as the other one?
Well, I only set. I didn't actually make them.
Skip right along about.
Well, no, I was just copying what I did last time, but I really botched it last time.
So you-
I did the.
Yeah, I
did the
get
same
that.
thing.
So you start with mod full, because you needed mod full to check your GVLMA.
Yeah, did the assumption.
Yeah, so you start with that. I mean, that's step number one. Make my full model, everything. Did my GVLMA,
Yes.
yeah, well, I violated assumptions. If I did my plots, you can also see that, yeah, it's very clearly non-normal. So we already have mod full. So I also made mod.null at the same time.
How do you decide what to put in null?
It's defined.
Okay.
Yeah, that's your null model. That is defined.
And, okay, so mod full is the same thing that we used on the GVLMA?
That's right.
Yep.
Yes.
Okay.
Where'd you see that? 16, 16 or whatever it was?
So how do we decide which things to remove from our full model?
And we'll get there.
You gotta, you do summary,
That is
right?
so not helpful. There
You
are so
do
many
summary
guys.
on here.
All right.
Okay.
Actually, no, never mind.
I understand that we want to get rid of the higher AIC values. So am I minusing this one, or this one, or this one,
Oh,
The simplest one.
this one?
This is where I'm getting confused. If you get the symbol.
All right, so we got to here and I said, okay, this is terrible actually, because I have all of these interaction terms, right? So I then went to mod.null and stepped forward. And that gave me a different response. And we're at that spot now where we compared it. We were at 16,610. This one is 16,615. So I'm going to go back to this model here and say, let's get through that point and see if we can get down to 1610 or 16,610, because 16,610 is better than this. We know that. It's better than that. So, looking at my table, well, I can't really remove that three-way interaction because that causes an increase. Causes a pretty significant increase, but it could give us a starting place. Maybe we remove it at that point. Remove the most complex and see if that changes it. Or we've got these two, age and die and sex and die. Remove one of those, make the new model, and then make that as our starting point and see if we get down to that 1610 AIC.
Why did you choose the age die and sex die?
It is arbitrary at this point. Both of these are slightly higher than this number. This is the number that R calculated, 16,615.47. It's possible that these are 16,615.5. They're slightly higher, but in computer programming, it doesn't matter. That number is higher, so R stops. And we're saying, no way. That difference of 2 isn't significant. It's not enough to make a difference, or we can't resolve it. So let's remove that and see what happens. In some cases, you may have to manually remove one or both of these, and then all of a sudden, once those are gone, this one's gone.
Where are you getting the 16, 610?
This. So I did going forward. So I ran both. So I got to here and I made my mod.sim. So then I started at the null and worked forward. And now what we're doing is adding terms to each of our models. And we get down to here. This is 16,610.
Okay. Cool.
Actual number is 16,609.5.
Okay, I have the same. I thought that you were working from the mod.full with 16.
No, so right here, this now is the simplest model, and we're looking at, okay, how do we get there? So I would probably go ahead and remove that three-way interaction first, since that is probably the highest order, and see what happens. Of course, it's going to try to add, But what happens if we remove that three-way interaction? Perhaps then, once we remove one of those other two-way interactions as a first step, it's going to cause a big drop. Big drop could be 3 or 4 AIC keys, but it gets us through that hump.
Does it make a difference if we run from control to the null model at the same time, in the middle, or do we need to start with control and do simplified?
You can switch the order, but you always have to go from both directions to get to a convergence.
Okay.
So, I just don't understand how you're choosing what to remove, because I thought you said to remove H and sec, but you wanted to remove the three-way interaction first? Or why is that?
At this point, it's arbitrary.
And which,
We're still 6 units away from our simplest.
which three-way?
And this is only doing one at a time. So let's just do it, just as an example.
Where does it say that? That's not on the last group of AIC.
Which one?
Nation size back
I don't know. Or, no, coming from the tool model?
Yep. Hold the back.
Okay.
I've got a three-way interaction.
Yeah.
Now, technically, if you have a three-way interaction, you need all of these two-way interactions. Since I have nation, size, and sex three-way interaction, I need a nation size interaction, a size sex interaction, and a nation sex interaction. All right? So I'm going to arbitrarily remove this one first, and then see if we add another term, are we going to drop below this 16, 6, 16? So I've copied it. Say mod 2 update. I made my mod simp 1. So what I'm getting, so I've already made that. That's where we ended. So I'm just gonna say mod 2 is update of mod.simp1, where dot squiggly dot minus are three-way interaction.
And mod simp one, that's from the full.
This was from my full. Yeah, from here I just copied that and said, okay, I'm gonna make that as my new. Mod simp, I probably wouldn't call it mod simp since I know it's not my simplest model, but I'm starting from here. So I make my mod 2, and then at that point I'm going to go ahead and step mod 2, where our scope is still the same. Lower equals mod.null, and upper equals mod.full. I'm going to run that. And you can see that immediately, our starting point was up high. But as soon as we removed one of these two-way interactions, it dropped our AIC to 16,614. And that's lower than the 16,616 where we ended.
Can you scroll up a little bit extra? I'm getting an air and stuff. Getting an air and stuff.
Yeah, I think you need to balance.
This can be coercion building.
I don't think you guys understand something.
When it goes down.
Yeah, you know me.
It's on scale in school.
And it's terrible.
So are we adding two-way interaction because the AIC was really high when we subtracted it?
But did we add it? We didn't add it.
Well, in your mod simp it says plus.
That is
size
this.
sex.
When we started at the full, it got us to this and said, this is our, according to step, this is our simplest model. So I copied this, copied it, called this mod simp, and just pasted it. Paste.
And then,
But we did not remove the three-way in that model.
Not in the mod simp yet.
We don't do anything.
That's when you do that.
That's when I skipped to the mod null and said, okay, hold on. I've got two different models at this point. So I made my mod simp 2 here and said, okay, I've got that. Now let me just go back and check my mod simp.1. Just out of curiosity, and I said, okay, hold on. Yeah, I've got a three-way interaction here, but there is no three-way interaction. I have two different models. So now I go back and say, okay, now let's fix this. How do I get to here? How do I get to sex, age, nation, sex, and sex-nation interaction? How do I get to that model?
Isn't that what you get coming from the null model?
It is, but did we get to the same model yet?
Okay, so we
No,
need
we
both
didn't.
the full and the null to have the same.
We have to get to the same.
Model, okay.
So we have to report both models, right? And AIC value.
I think you're trying to get them to be the same.
We're trying to get them to be the same. So when we wouldn't report them yet?
We wouldn't report them.
Not yet.
So is
Okay,
it,
well, I'm sorry, I guess I'm on.
is the null,
That's wrong, lots, I don't know what two models report.
is the.
Yeah, we don't have two models yet. So we've updated it, and now we remove that three-way interaction. That's the most complex interaction. And when we remove that, now all of a sudden we dropped. We got to 614, it worked, it worked, it worked, and now we get to this model, this simplest model, which is nation, size, age, sex, die, nation, sex, age, die, sex, die. That has 1610.74.
Can you go through the chunk, with mod simp from the full model?
This one?
Okay, so when you get your null model, so when you do rolling your null, if they don't match, you're always trying to get it down to that null.
We are always trying to get them to match. So it could happen with the null is that you hit a spot where adding a variable results in an increase. It stops. But that increase might still be too large than the AIC coming from the full model.
Oh, so then you have to do that.
More than likely, it's going to happen going backwards.
Okay.
What is this exactly? I thought it was mixture.
Yeah, you didn't
Which one?
take this, copy it.
Yeah, but then I'm moving around. Oh, okay.
So we're close. Now we've got Matt's problem on where to report, because we still haven't converged, but we know where we needed to get, and at this point, our AICs are within 2, right?
There's not enough?
What's that? We haven't converged. Right? Mm-hmm.
Yep. Now we just start.
Now, yeah, so now we're gonna look at, okay, well, which ones? We've got two-way interactions, and now I'm looking at, well, which one wasn't in our simplest model here? Well, sex nation was included, so what I'm gonna do is probably start with sex die or age die and take that out, see what happens. But we're at that interesting spot where we've got all of these models that have all the AICs within a certain period. This is probably where I'm gonna start making a model or making a table and recording the AICs for each of these. All right? Because now we need to say anything within 2 of this value here. Anything within 2 of this value, we should probably report. What you're gonna see is that it gets kind of rough for all the interpretations. But it,
Started rough. Getting rough.
Okay, so
Getting
whenever
rougher,
I
yeah,
took
it's
out
not
the
getting
three-way
rougher.
interaction, my AIC got higher. Does that mean I should put it back, or?
what do you mean when you dropped it?
Yeah,
So I'm sure you got to this, right? You copied it, you made the new model,
yep, made one sense. Yep, and then, yeah, so, my output for that had a higher AC than it did, or AIC than it
Wait,
but when you ran it, it should have dropped it should have started dropping terms.
I agree that it should have. I mean, I don't know what to tell you, I got a higher AIC.
so, what's that?
I'm sorry.
I don't think we're at it yet.
And then you'll get that.
It goes from 19 down to like 14, or it's 14 real quick.
11.
What was your knowledge? Hold on, let me,
So, I tried to take out X die, and it says,
So keep cutting off the most of
it's still in, there's a here.
No, it's gave a plus.
Okay.
So remember, it's gonna add and subtract.
Okay, so, yeah, it's just a formula has plus X die,
fair enough.
which it shouldn't.
I just updated it again to minus each die.
So you took out sex die first?
Yeah.
Yes.
Alright, let me try it.
Well, it still has each die in my model. So I just.
Okay, when you're choosing which AIC to remove, does it make a difference if, like if it's a minus size has the largest AIC, does that mean I should add size?
No.
No, okay.
The only reason we did that was a 3-way interaction. That was a very complex term.
That's why we subtracted it?
We subtracted that. We subtracted that most complex term and said, let's get rid of that and see what happens.
So we subtracted it because it was most complex?
Yep.
I thought you just take out whichever one has the highest AIC.
No.
Oh,
We took it out because it was the most complex term at this point. So we can ignore the pluses. We're not gonna add anything back.
okay.
So our choices are these: age die, sex die, or nation sex, size and sex.
Okay.
Okay, so I tried to run this a third time now, minus age dot, right? That's the next thing we're gonna do?
Minus. I was gonna do sex die.
Okay.
It's copy.
I can just switch that. But then when I run this with the step function, text die keeps showing up in my stuff. That's my question. Which means I could just stuck at the update function.
Yes. So we dropped it out. It's not in mod 4. Right?
Yes.
So what it did was, when we dropped it, it gave us 16,611.29.
No.
That's our starting point.
Oh.
That's our starting point without it. So it's gonna add and it's gonna subtract stuff. So when it added, it actually got a smaller AIC value because it added it back in to give us a 16,610.74.
Mine didn't start at that.
With sex die, it does. Did you rerun it? Or are you still working with age die?
I've changed it to sex die. My starting is 16,620.
Then you didn't start. You didn't make it. So no, because that is still cloth.sim2. Did you remake cloth? Did you remake this?
Oh, yeah, no, I enjoyed that first few parts of this class. What?
You ran your step.
No.
You rubbed it.
Did you get that?
Full send, right?
Right,
You ran your
we're
step.
working on,
And you got to
Did you get that exact number?
Yes,
Well, that was with Sim
got
two.
exactly what he got so far.
I'm like, put 5 on.
What? I mean, look at this part up here. You look at this up here.
Oh, and let's know.
No, that's Sim 2, right? And then you ran your step function. So now this is your simplified model for Sim 2. This should be now Sim 3.
So cloth Sim
So
three
copy.
equals that.
And go cloth Sim 3.
Oh, my stuff is just bad.
There. Now what you're doing is
You're
updating
getting
this.
this, I think.
I don't know, whatever
You're
you
getting
call
this
it.
part. And I have like, I don't know what how you start.
Well,
Or it says starting at.
we're doing this.
What
Sim
happened to
3.
cloth Sim two? I feel like we can just.
No,
I feel like
we're still, all right. I'm gonna go up to the board and hopefully you can get what's happening here. Our goal is to iteratively remove and add terms until we get to the simplest model. And that means we're gonna have to manually make our own models and force R to get through these local minimum. Use the letters. Model is going to use letters. All right, I make that model. I know, I make this one. No exploratory variables at all. All right. So now I'm going step, taking a mod full model, and our scope. I'm gonna write the scope out once. It's going to be bounded by our null model, and our upper is our full model. And then we're going to invoke the step function. The step function is going to go through, figure out, and let's say our best model, we're going to say mod 1 is whatever this step function gives us, which could be, let's say, y is a function of a plus b plus c plus d plus ab plus ac plus bc plus bd plus ac. Massive model. That's what we got for mod 1. So then we continue and say, okay, well that's what we have for mod 1. Let's go back and start then at the beginning. We don't know what our lowest AIC is. This gives us our lowest AIC at this point. We don't know if that's the answer. We now start at the beginning with the same scope. With our same scope. And let's say then this one comes up. When we're done, we say, okay, mod 2 now is ln y is a function of a plus c plus ac. And if we looked at our AIC, let's say this AIC is 110, and this AIC is 25. Which one's better? 25. Did we get to the same model? Nope. No. So it's possible that someplace between here and here, there's an AIC with, let's say, 15. We don't know that, because according to the computer, it's only comparing the numbers. If they differ by 0.01, whichever one is higher, R says we don't want to bother with it. So we come up with these two values. What we're going to have to do is say, okay, we're going to take this model now. and we're gonna update it. We're gonna call this mod 3. We're gonna update it. Mod.1. And we can look at the AIC chart and say, okay, well, we can pick out whichever one is gonna remove it, but looking at this, we're gonna start with the most complex term and go from there. So we're gonna force it and say, I wanna remove that. Remove that three-way interaction, and then continue with our step. And this time, we're starting at mod 3, but we still have the same scope. Still set our upper and lower bounds. And let's say at that point now, we have another model that came up. After it ran, we have a linear model that said the AIC, let's do A. Say we get to that. All right, but when we look at that AIC, that's only at 50. Which model is the best? We're still this one. Did we get to it yet? Nope. No. So we're going to have to force it to get through this point. So I'm going to make a new model where I'm going to update this mod 4. And at this point, I have to make a decision. What am I going to remove? Am I going to remove a main effect? I mean, I know I don't have B or D in here, or am I going to remove a two-way interaction? General rule of thumb is to start with the most complex term. So I'll start with the BC. I could have tried AC, but I kind of have a feeling we're going to need it in our model. So I'm going to start with that BC and see what happens. And perhaps it works. Perhaps it doesn't. But we're still going to check. So step mod 5, again, same scope. And this time we get a model that says we get to this. No, that won't happen. Just say we get to that. Are they the same models?
Yeah.
Yes, we've converged. We've gotten to the smallest AIC. At this point, we're done simplifying. So this is the whole point. This is what we're trying to do. We're trying to get, if we start at a full and work backwards, we can get to the same AIC as if we started at the bottom and started adding to it. That's our whole goal. And you can use some of this information as a guide. Since this AIC is lower than this one's definitely better. So if it's definitely better, I can look at these terms and say, okay, well, which terms aren't in this model? Let's remove one of those and see what happens first. And it's a possibility that if we remove one of the terms, it's going to say, no, we're at the simplest model. Okay, that's fine. Let's remove another term and see what happens. Maybe that term is the one that's holding us back. That's what you would get with that three-way term. If you removed one of those two-way interactions, it probably would stop and say, no. This is the simplest model. So what you needed to do then was to figure out, okay, well, let's remove the three-way term and see what happens. All right? We can do this by hand by looking at ANOVA tables. But hopefully you see that it is going to be super long and super tedious to do that.
Even longer than this.
Right? So that's a whole base. We ended up in two different spots. Let's now start forcing it to get to this spot. And then, as Matt says, you're going to see, this is going to be the case a lot of times, where, change this, this one's at like 30, and this one's at 25. And then when we get to this spot, we're at, let's say, 28. So you end up with several models all within a tight AIC band. And at that point, as I said, you should probably report all of those that are within 2, but focus on the one that has the lowest AIs.
So definitely the one that was.
Report that. And I've seen this happen. Like, grad student came up.
It's an exact question.
Here, factory skill.
That question is why the sex and why
That
the
should be lower.
sex and die was re-included.
Oh.
I can tell you exactly.
Well, now you can put them in any order, but the mod.null is lower.
It re-added itself.
Yeah, that's what I mean,
Yeah.
it's what it looked like happened, so it's saying that, like, you can't take it out, basically.
Yeah,
Yeah, okay.
yeah, it was lower, but once you remove the next one, then it stays out because that's that. So,
So you have to take out
so
age
you
die.
remove age die, once you do that,
Then you can
that's
take out
low,
set die.
yeah, the new model is lower than with age die and or with the sex die.
4, 5, minus, and then
You pick one.
the one I didn't do last time.
So I think I did sex die up here. I did sex die and it stopped. Is that right?
It like re-added sex die.
Oh yeah, it re-added sex die is what it did. So that I don't think worked.
So you go with age die after that?
Yeah, so then I would go with age die and see if that helps us.
Would we need to keep the AIC
Yeah.
number for the one with sex die? Because it's still a thing too? Or can we just update?
Yeah, we're updating. We're ultimately going to try to get to a spot. So both times when I did age die,
Just give me the same thing?
yeah, added it back in, and then sex die,
Yeah, just added age die back.
and it kept adding it. So what do we do?
Keep leaving it.
Well, no. Now I'm going to remove them both.
Okay. You can do that. Okay.
Yeah.
Yeah.
Because maybe it's the combination. And at that point, you can see our first step, we can remove a main effect.
Minus age die. Put comma. No dash.
And now at that point, it gets us to, yeah, so we remove both. And I can just do it all in one in that update function.
That's the one. That's the one, baby.
But when we're doing it with our data, right, we don't want to just delete.
Okay.
Yeah.
You see what I'm saying? Like,
That's-
we would just want to keep creating mods.
Yep, and that's why I kind of just number them.
Okay.
So if I ever need to go back, I can.
Yeah.
All right, what do you got?
I just can't get the term to stay out of the model.
Did you remove both of them together? Hopefully, we're starting at the same spot.
You put a comma or did you put a minus in between age and sex die?
I put what?
Ooh, yeah.
Put a minus.
No, we're removing both of them. We're gonna remove both.
If we try it again.
Yeah,
Oh,
so,
look, now it's gone.
yep, yeah, so what we did is we want what's left and what's right, and we're gonna remove that term, and we're gonna remove that term.
Okay, yeah, I just
I don't know if you use parentheses, like minus and then parentheses, the terms plus together, maybe that works? I don't know.
Okay.
Alright. Well, I'll see if I put together another data file that kinda helps get this down. It's rough, but kinda looking ahead, this whole business of getting through this is where the G-multi package comes into play. Because it'll automatically create all of your models
and then calculate AICs for all of them. So that way it kind of eliminates this whole, well, let's remove the term by hand and see what we get, or let's remove this term by hand and see what we get. It's rough.
Nice.
It could be worse.
All right.
Oh, yeah, that's what, yeah, thank God for our dude allocates this class.
You can analyze it.
Now that I have something.
All right. Hey, there are defenses coming up.
Yeah.
All right. And typically they're going to be open to come hear the presentation and support your fellow graduate student.
That's perfect.
Blake's at 2 o'clock on Friday, next Friday.
Oh.
Upstairs, I think. Upstairs. Yeah, there should be flyers. Those of you that don't know, we need flyers. All right. And Cameron is coming up. Yeah, someone said it was Monday.
That's false.
Yeah, that's false.
She's probably trying to say it wrong. Tricking people out.
I don't know. I was gonna tell her it's due like 7 a.m.
Oh, I'll print it out for you. Everybody.
Oh, you're gonna print out Cameron's? Who wants to print out Blake's? Yeah. All right. Yeah. Don't forget about those, and it's something you get to see. You get to support them. You get to ask questions, and then everyone gets kicked out, and they get hammered by their committee.
And they get destroyed. Torn